right, today we are going to discuss counting rules. So 3 things. Fundamental counting principle, permutation, and combination. Alright? So first of all, the fundamental counting principle. If event A can occur n different ways, and event B can occur n different ways, then the event A and B together is going to occur n ways. A classic example of the fundamental counting principle is putting together a sandwich. Okay, like going to Subway. Okay. But this, the sandwich shop we're going to talk about in this example isn't going to be quite as intense as Subway. Okay, Subway has a lot of options. But the one we're going to look at, we have 5 different types of bread. We have 4 different types of cheeses, or you have the option of no cheese. 4 different kinds of meat to make your sandwich. Okay, so what I like to do, okay, we have 3 different types of things to make our sandwich, right? How many types of bread? Times how many types of cheeses? Times how many types of meat? 4. So we have 100 different types of sandwiches we can make. Alright, we really don't have very many choices, and we have 100 different sandwiches. Can you imagine the possibilities at Subway? All right. Some more examples of the fundamental counting principle. License plates. Also a classic example of the fundamental counting principle. Okay, so let's just assume, okay, I don't think this is the rule, because we have some license plates that we cannot have, all right? Suppose license plates consist of 3 letters, 3 numbers. Now that's true for most of Nebraska. Omaha and Lincoln, 3 letters, 3 numbers. Okay. How many different license plates are possible if repeats are allowed? So we have 3 letters followed by 3 numbers. How many letters are there?
26.
Please remember that. So we have 26 times 26 times 26. How many digits?
10.
Very good. We have 0 through 9. So there are 10. We multiply these numbers together. What do we have?
17,576,000. Yeah.
Now, what if Okay, now obviously this isn't really true for Nebraska because first of all, in counties, like in Kearney, the county number is 9, so they have 9 dash and then like 4 or 5 numbers and letters. Okay. But if Nebraska license plates for all like our Omaha, this is how many there would be. Except we probably have to subtract a few because there's some 3-letter combinations that would not be appropriate for license plates, right? We don't need to say them aloud. Now, what if repeats were not allowed? We still have the 3 letters followed by the 3 numbers. But if repeats were not allowed, how many choices do we have for the first one?
26, 25, 24.
If we cannot repeat, we've already used a letter, so the second letter, we only have 25 choices. Now we've used 2 letters, so now we have only 24 choices. Okay? Now our digits. We haven't used any digits, so our first digit, we have how many options?
10.
Times
9,
times
8.
8. Alright? How many choices does this create?
11,232,000.
Significantly less, right? It's amazing the difference between having repeats and having no repeats. Okay, I'd like you to read through this. Let it soak in a little bit. Gather some ideas.
Oh, 3 times 10.
All right, how many batters do we have? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now, keep in mind the pitcher cannot bat in the first 4 spots. So how many players do we have to pick from for our leadoff batter? 8. How many?
7.
7.
6.
6 and 5. Okay. Now these first 4 spots, this is where the pitcher cannot bat. Once we get to the 5th spot, the pitcher can bat. So instead of 4, this number is
5.
5, because we have the 4 non-pitchers and now the pitcher. So 5 then.
3, 2, 4. And you get 201,600.
Good thing we're not GMs, that's a lot.
Okay, now that's a lot of
Batting combinations.
unique batting orders, isn't it? Okay. Makes the coach's decision a little difficult, right?
No, it makes it easy. It's so much to choose.
Okay. You're so encouraging. Okay. Next thing I want to talk about, permutation. What's a permutation? Okay. Order is important with permutations. Now, in your calculator, you'll see it like this. NPR. Now, what does that mean? I told you on Friday the definition of the mathematical definition of a permutation or combination. A permutation, we have n factorial over n minus r factorial. So it's very similar to a combination, except one thing in the denominator.
Isn't that just another n factorial?
What's the difference?
In a combination, we have an r factorial down in the denominator as well. Okay? Because that's accounting for it, or it doesn't matter. first of all, in a seating chart, is order important? Would my seating chart be different if I switched Malik and Jackson? Yeah, it would be. Because if I switched you two and Malik was gone, then if I didn't switch my seating chart, the sub would count the wrong person. Okay? So, order is important in a seating chart. So in this class, how many seating charts could I make? How many of you are there? Count yourselves. 22. Equal what the two people got? Two here today.
Oh, yes.
So 23?
Yeah.
Okay. So if there's 23 students, how many different seating charts could I make?
Yeah.
How do we do it?
23.
Or you can say 23 factorial. Right? Or you can say 23 permutations of 23, which, and minus r. Okay? When you're permutating all of your objects, you can just write it as the n factorial, because you have 23 spots to fill with 23 people. Okay? How many seating charts could I make?
2.59 times 10 to the 22nd.
I am not going to make that many seating charts.
Let's try it.
Okay.
Let's do that right now.
That's your challenge, Chase. All right. Now, how many different ways could I select a president, vice president, and secretary for this class? Is order important here?
Yes.
Yes. All right. If Chase is president and Nick is vice president, that is completely different than Nick being president and Chase being vice president. Okay? So you can look at this through two different ways. You can say, all right, I have a president and a vice president and a secretary. I have 23 options to pick for president, 22 options for vice president, 21 for secretary. Or you can say I have 23 people and I want a permutation of 3 of them. These two mean the same thing. I don't care how you do it. What? What about it? Okay.
It's like 3 A's and 2 N's.
Okay. Now, don't know why I have any screenshots. If I'm looking at how many different ways to arrange ABC, I could say ABC, ACB, BAC, BCA, CAB, and CBA. Okay? That should not be 6 factorial, should it? I was excited. It should be 6, right?
Yes.
And 6 is what?
6.
Yeah?
3
factorial.
factorial.
It's 3 factorial. because I have 3 letters, I'm permutating, right? Come on.
Wait a second.
No.
Why wouldn't it be? There is mom and mom the same.
No.
OMM and OMM, is that the same? MMO, those are the same. So these 3 don't count. So how do we only get 3?
Crossed out the other 3.
Put in 2.
Okay?
Oh,
We have 3 factorial different ways to rearrange 3 letters, but how many of them are the same? So we have to divide by 2 factorial. Because we have to account for those 2 ends being in different places, but they're the same letter.
Do you do the number that there are?
Yes.
So what if you have 2 of those?
Like banana.
Wow, that was gross.
Okay. Banana. How many letters are in banana?
6.
There are 6 factorial different ways I can rearrange 6 letters. However, we have some repeating letters. A is repeating how many times?
3.
So we need to divide by 3 factorial because I can rearrange A, the 3 A's that many ways, but they're all the same. Also, we have 2 N's, so we also need to divide by 2 factorial. So how many ways? 60?
12 times 5 is 60.
Cool. You find me papillion. How many ways can we rearrange the word papillion?
9. I got 60,000.
Now, when you have more than one number being multiplied in the denominator, it needs to be in parentheses. Some of you are having some issues because you're forgetting parentheses. How many letters are in papillion? Okay. These are repeating I's,
L's.
L's, 45,000 what? Do we agree with that number? Okay. Questions? Okay. Now remember back here when we were taking 23 people and selecting 3 in a particular order, we had 23 permutations of 3. Now let's talk about combinations. And we've already talked about combinations. Combinations order doesn't matter. Now remember, our mathematical definition, NCR, was n factorial over r factorial times n minus r factorial. Okay? Your calculator's going to do that for you. Okay? How many ways can I choose a 5-person committee from this class? Now, a committee, if there is no rank within our committee, president, chair, co-chair, whatever, order is not important. So there's 23 people, right? In this class?
Right.
Okay. So our 5-person committee, how do we write it? 23 combinations of 5. $30,000 what?
645.
Okay. Now, basketball season's wrapping up. Where is wrapped up? How many ways, if I was the coach, could I put 5 Titan basketball players on the court if there are 15 suited up to play? If I'm just putting 5 players on the court, is order important? Now, if I said 1 post, 2 guards, 2 wings, whatever, okay, that is when order would be important, and position has not been mentioned. Okay? So how do I write this? 15 combinations of 5.
3,003.
Question, is a permutation or a combination going to give you a larger number? Permutation, there's going to be more ways because of that order being important. Okay? Here's a good one. 12-person swim team from 10 boys and 15 girls. And I want the same number of girls and boys. So 6 boys, 6 girls. What does the word "and" mean in mathematics? I have 3 different answers. And means multiply, or means add. And that's something we'll get in more tomorrow with our probability. Now, is that 12 important in our combinations?
No.
Kind of, but not really, because we're breaking it up into this 6 and 6. Okay? From our 10 boys, I want to pick 6 of them. And out of our 15 girls, I want to pick 6 of them. So the fundamental counting principle, I need boys and I need girls. But we have to do combinations for each of them.
Really?
Oh, okay.
Yeah.
Like that. What, Mike? I need to calibrate myself. Are there any questions about these 3 topics? This is it. Okay, I only gave you a few examples because I know you had a lot of examples last year. Right?
Word.